Okay, it seems like everybody is now connected, so let's start with this new microlearning. Hello again, thank you for being here. I'm Carlos Martinez, responsible for the training department here in SODECA, and I'm with my colleague Martí Prat, that is going to be the teacher, the presenter today. He's smoke control and CFD project engineer at the project departments here in SODECA. And we are talking today about jet fan ventilation system for car parks. I think it's a very interesting, very trendy topic. So I hope you enjoy it and take advantage of this topic. As always, a little bit of housekeeping. We are going to share with you the presentation, the PDF, at the end of the session. So at the end of the session, you will be able to download it. And as always, we will have a Q&A question, a Q&A time also at the end of the presentation. So you can write down your questions from this moment, and we will answer it at the end of the session. So no more for my part. Martí, the floor is yours, and thank you so much for being here.
Thank you, Carlos, and thank you all for attending to this presentation. I will try to explain mainly the jet fan ventilation system for car parks. To do so, I'm going to explain about the standards that refer to these types of ventilation, and I will mainly focus on explaining how to do a good design. To do so, we mainly have two different main goals. The first one is the pollution. We want to reduce the pollution levels, the carbon dioxide, carbon monoxide, nitrogen oxide, these different gases produced by vehicles to acceptable levels, so the occupants do not breathe this type of gases. Also, there is another main goal, the explosion safety. By having this daily ventilation, we are already reducing these substances emitted, flammable substances emitted by these vehicles to a lower explosive limit. So we are declassifying this car park area of an area of explosion risk. Also, the fire safety. We have two objectives. We have two types of ventilation that we can have in a car park. Smoke clearance. The idea of a smoke clearance is that we want to help the firefighters to allow a speedier clearance once the fire has been tackled by the firefighters. And the system also helps to reduce the smoke density and temperature during the course of the fire. Another type would be smoke control. This is much less common. And the idea of this system is to aid access to the fire brigade to more quickly locate and tackle the fire. So you have an area free of smoke, and the firefighters can access to the car park easily and locate the fire and tackle it. And also limits the density of the smoke and the temperature during the course of a fire, so it also helps with the evacuation of the car park. For the smoke clearance, we have the British standard 7346/7 of 2013. In clause 9, in section 9, we have impulse ventilation to achieve a smoke clearance. This section presents two objectives, very important objectives. So the aim of this system is, as I said, assist firefighters by providing ventilation to allow a speedier clearance of the smoke once the fire has been extinguished. So once the fire has been tackled, then you activate the system activates automatically to clear the smoke produced by the fire. And also the system helps reducing the smoke density and temperature during the course of the fire. But it is important to notice that this system is not intended to maintain any area of the car park clear of smoke and limit the smoke density or temperature to within any specific limits. This would be a smoke control system. For the smoke clearance, to calculate the airflow that we need to extract, we have these two ratios. Basically, for the pollution mode, we calculated based on these 6 air changes per hour, and in the fire mode extraction, we have this airflow based on the 10 air changes per hour. So basically, you calculate the volume of the car park and multiply it by these air changes per hour. And you dimension the extraction fans based on the most favorable airflow that you get from this calculation. And instead, in a smoke control system, we refer to the TS12101, part 11. The smoke control system, as I said, is intended, as we see here, to maintain an area free of smoke, so the firefighters can approach to the fire and locate it and tackle it. This system implies having a calculation not based on ratios, but based on airspeed through the section of the car park. So based on the width of the car park, we get an airspeed with the difference in between if the car park has sprinklers or not. If the car park doesn't have sprinklers, the fire source has much power, much more heat release, so the airspeed needs to be higher. Here we have an example of a calculation. We have a car park of 3 meters height and a width of 30 meters. So we get the airspeed from the table and we multiply it by the section of the car park, so the width and the height. And with this calculation, we get the airflow, which is very different if we have sprinklers and if we have no sprinklers. As we can see here, the air changes that we have with this calculation compared to the smoke clearance system is much higher. So it implies dimensioning much bigger extraction fans. The jet fans also need to be bigger, and it implies more resources to achieve this kind of ventilation systems in car parks. We have different types of ventilation systems in car parks, but this does have many restrictions, also explained in the RIGIS standard. If we want to have a natural ventilation, the openings must be in opposite facades, and these openings must be of an area greater than 5% of the effective area of the car park. This implies having big opening surfaces to have this cross ventilation from one side to the other. If these openings are way too far from each other, sorry, we can also assist this natural ventilation with impulse with jet fans. Another type of ventilation would be mechanical. We can install a duct network having an extraction and a supply. So supply air, fresh air inside the car park, and with the extraction grills, the extraction ducting network, we extract this air. If instead we want to have an impulse ventilation system, we can remove all this duct network and install jet fans under the ceiling. This implies having much more visibility, and it is much easier because it is plug and play. So it's a different system which totally works in this kind of ventilations in car parks. The extraction point requirements, also explained in the British standard, are that when you calculate the airflow based in these 10 exchanges per hour, for example, for the smoke extraction, you need to consider at least 2 fans for this extraction. So in case one fails, at least you have the other that will still exhaust 50% of the airflow. Of course, SODECA fans doesn't fail, but in case some fan fails, you have the other fan to keep extracting. We have also this element, the backdraft dampers. So in case you have this parallel arrangement with two exhaust fans in parallel, you want to add these backdraft dampers to avoid recirculation between the 2 fans. In the British standard, it states also that these smoke extraction fans need to be certified to exhaust at a temperature of 300 degrees for a period not less than 60 minutes. And the certification must be made with the EN 12101 Part 3. This is also explained in the TS 12101 Part 11 of 2022. And SODECA have smoke extraction fans F300 and F400. This is also very important when we produce these fans, smoke extraction fans. We also have a CE declaration, meaning that these fans are being produced to comply with the requirements of the standard. So they are being made as they were tested when they were certified. For the extraction points position, the British standard says that consideration should be given to the location of the means of escape within the car when positioning the extraction points. We can see the picture here. This is in the Spanish standard. The Spanish standard, what says is that the extraction point should be at a minimum distance of 10 meters from escaping point. This is because you are extracting the smoke, so you are attracting the smoke towards this area where there is people evacuating. So it is important to place as far as possible these extraction points. And we also have this information that is explained in both Spanish standard and TS 12101 Part 11 of 2022, Annex B, that says that the extraction points should have a maximum of 30 meters from the borders and 60 meters between them. This is because we want to have an uniformly distributed extraction in the border of the car park. We refer to these standards because the British standard lacks with some of this information, so we get information from other standards that are also for ventilation in car parks that allow us to have a good design. That's what we want. For the fresh air supply, the idea is that the fresh air supply fans must also be certified F300 as long as they are inside the restaurant, inside the car park, for instance, because these fans may be exposed to direct radiation from a car in fire. And they also must have the C declaration, and they must be also certified according to the EN 12101 part 3. For the fragile supply, it would be more or less the same as the extraction in regards of the uniformly distribution. As we see here, we should have it as uniformly distributed across the whole width of the car park as possible. In the Spanish standard, it stays the same as the extraction points, so there should be a maximum distance of 30 meters between the supply point and the border, the wall of the car park, and a maximum distance of 60 meters between 2 points. Also, when positioning the supply points, it is important to notice where do we have the evacuation points. As long as possible, it would be recommended to have these supply points near these evacuation points, because this way you are providing fresh air inside the car park, so the occupants can evacuate easier. And also near a RAM, because the RAM is also a great fresh air supply source. So you want to consider this as well when locating the supply. The jet fans, basically the principle of impulse ventilation of these fans is based on the induction, which is mainly that the jet fan pushes air at very high velocities at the outlet of the fan, and this produces an air entrainment inside the cone of the jet fan. So the volume of air that the jet fan pushes is much greater at the end of the cone. This allows to have a sweep across ventilation of the whole width of the car park. As we see here, it is also very important where do we position the supply points and the extraction points. They should be in opposite facades of the car park in order to allow this cross ventilation. And in this arrangement, the jet fans are very important because we uniformly have uniform velocities across the whole car park, and also we eliminate these possible dead zones where we could have accumulation of pollutants or smoke by installing these jet fans properly. In QuickFan, which is a tool that you can download in SODECA.com, we can get all the information, all the characteristics of the jet fans. In this case, what we want is to get the data of the cone of the jet, in order to draw it when doing the jet fans layout. We say that the cone ends when it gets to an airspeed of 1 meter per second, because we said that this airspeed is not enough to keep moving enough volume of air and keep sweeping the whole car park. For the jet fans position, it is highly recommended to install always the jet fans across the roadways. This way, you are maximizing the jet fans effect and also avoiding any obstacle that you could have in these middle areas where there are cars and columns that can be an obstruction for the jet fan. So the idea would be this below, where we have the jet fan, we draw the cone, and when the cone ends, we place the next jet fan, so we have this flow continuity, and also the cones and the jet fans in parallel, the cones are in contact with each other, so we are sweeping the whole width of the car. When installing the jet fans, it is important to notice where we have the obstacles. We have to try to avoid these obstacles in order to maximize the jet fans effect. And to do so, I always recommend to install the jet fans lower from the obstacles, at the lower height. If it is not possible, the jet fans should at least comply with that. So the lowest part of the jet fan is at the height of the lowest part of the height of the obstacle. And since the jet fans also have a deflector which deflects the jet of the fan, we can calculate with pure trigonometry here the inclination of the jet and calculate this bit distance, this minimum distance that the jet fan should have in front of the jet fan. Also, when calculating and when dimensioning the extraction fans, what we do in such projects, we calculate the induced airflow by jet fans. The jet fans, as I explained earlier, move a much greater volume of air at the end of the shaft. And all this air volume needs to be extracted, otherwise it recirculates. And we want to avoid that because otherwise we are not extracting pollutants or the smoke in the event of fire. To avoid so, we have always to dimension the extraction airflow based on the induction airflow produced by the jet fans in parallel. In this arrangement, in this layout, we can see that the induced airflow is way too big, 9 by 25,000. To avoid that, it is recommended to have, for instance, in this layout, the supply on the left and the extraction on the right, so we have less jet fans in parallel and the induction airflow is much lower. So it would be like 2-3 times 25,000. So the extraction airflow calculated based on the tenor changes per hour is already enough. For the design, the British standard shows this figure of an example where we have the supply on one side and the exhaust at the other side, and the jet fans placed in the roadways. So in this case example, we have the exhaust at the left, the supply at the right, so at opposite sides, and we have all this fresh air supply inside the car park, pushed with the jet fans, avoiding any possible dead area, dead zone that we could have. And we extract it at the end of the car park. So we are cleaning all the car park of pollutants, and we are fast enough cleaning all the smoke in the event of a fire. It is also very important, in the British, it is said that the delay is necessary to ensure that escaping occupants are not compromised by the action of impulse fan system. So basically, the jet fans need to have a delay because otherwise these jet fans produce turbulence and stratify the smoke layer, so the smoke can go down and difficult the evacuation. That's why we have a delay with the jet fans activation. In this diagram here, that we can find in the TS 12101 part 11 and the Spanish standard. It states that the daily ventilation is stopped when the fire is detected, and the alarm starts, and the extraction and supply fans start at 10 air changes per hour. Once TD has passed, TD would be the greatest time between the evacuation time and the sprinkler system activation time. In most of the car parks, it will usually be the evacuation time, but it is important to have this delay also waiting that the sprinklers activate as well. Then past this TT, this time, the extraction and supply fans are activated at maximum capacity if they are not already with the 10 air changes per hour. And past 1 minute, so we have enough time to allow all the evacuation of all the occupants inside the car park, we then activate the impulse fans at maximum capacity. For the CO control activation, we basically have the CO sensors that are installed trying to cover as much area as possible of the car park. And they are connected to the CO central that we have in SODECA. This CO central has 3 relay outputs per zone, up to 32 detectors per zone. So in case it is detected that for instance, the CO sensors are detecting, the CO detectors are detecting that the levels reach 25 ppm, then the system activates at a speed to reduce these CO levels. Here we have an example of the activation. For instance, we could have this activation where when 25 ppm are detected, the jet fans activate at low speed and the extraction supply is off, it's not activated, the extraction fans and supply fans. Usually this can be enough to reduce the CO levels. So this is also very efficient in regards of electric efficiency. When it reaches to 35 ppm, extraction and supply fans activate at low speed. Jet fans always at low speed because this is during daily ventilation. And when it reaches to 50 ppm, the extraction and supply fans at high speed. We can also have this activation based on a proportional speed with BSDs and control card that regulates the fans, the extraction and supply fans speed based on the different levels and this 0-10 volts signal. This would be all. Feel free to follow us on LinkedIn if you want, where we keep updating all the late, all the new ventilation solutions. Thank you for your attention, and if you have any question now.
Yeah, thank you, Martí. Thank you so much for your nice presentation. Let's allow Martí to have a sip of water, and meantime, I am going to share with you the presentation, and then we start with the Q&A time, okay? So let me share with you the PDF of the presentation, and you can now write your question. We have one or two, Martí, during your presentation, so I'm sure that there will be more. Okay, I am sharing the presentation just right now. So you are supposed to see it and to download it in the document tag in the control panel, so you can download it. Anybody has any problems can write to Martí or to me, and we send you the presentation. Okay. So Martí, let's start with the question time. Okay. Okay, we have a question from Joaquin Monteiro. The question is, will the supply air have to be placed close to the floor?
That's a good question. We recommend always to install it on the half part below in order to not compromise the smoke layer that we have at the top. So when you are supplying fresh air from the outside, you are cooling down this smoke layer, and you are making the smoke go in the part below the car park, compromising this evacuation. So as long as possible, always try to install it, yes, in the half part below of the car park.
Yeah, to not compromise the work of the smoke zone, no? Okay, I don't know if we have more questions. Yes, we have more. Let me just remind you that this is a whole program of microlearnings, of trainings. So we are having more in the next month. So stay tuned in LinkedIn to assist. Okay, Martí, we have more questions. Another from Pedro Neves. He said, in the presentation, it was considered an additional extraction flow of 250,000 cubic meter per hour per jet fan. No, sorry, 25,000 cubic meter per hour per jet fans. This value is standard or can vary with the size of the jet fan selected?
It varies. It depends on the thrust of the jet fan and the amount of airflow that these jet fans are pushing. So we usually say that for a small jet fans like 29 or 35 size, it is usually between 25,000 and 30,000 cubic meters per hour. If the jet fans are bigger, can get to 40,000 cubic meters per hour. So the induced airflow, of course, it's bigger because the jet fan is bigger.
Okay, let's go with another question from Juliano Mella. What is the maximum permissible distance between inlet and outlet?
Between inlet and outlet,
the longest you can, no? The longest you can.
Well, actually, it changes in case we have natural ventilation. In most of the standards, it is said, for instance, in the Spanish standard, we say that there shouldn't be any distance larger than 25 meters from any part of the car park to any opening. If we refer to mechanical ventilation, we say that in car parks that are larger than 100 meters, since the distance is way too long, all this mass of airflow that needs to be moved is too much. So we recommend then a reversible system with jet fan reversible. So in case, for instance, a fire is detected in the right zone, the reversible jet fans activate, pushing the air towards this zone and extracting from this area. it's difficult to explain. I hope it is understood.
Yeah,
But the idea is
not,
that
it is not all clear. Juliano, you can write, Martí, you have the email just in this slide, and we complete the information, okay? Okay, Martí, more questions. From Hanan Barelli, what are the rules for the quantity of makeup air?
That's a good question as well. We always refer to the, in the Spanish standard, it is stated that it should be an 80% of the extraction airflow. We always have this percentage difference because we want always to depressurize the car park. And we also have some natural sources, even if our basement, so we always want to have this bit of difference. We always refer to this number, the 80% of the extraction airflow. The idea of depressurizing the car park is because you don't want smoke or pollutants get into evacuation points, stairwells, or so. So you want to depressurize the car park.
Okay, let's with another one from Ferdus BK. Can you get back to the CO activation slide, please? When the jet fans should work at high speed then? In daily ventilation, never, no?
The idea is that they should never work at high speed because there are occupants circulating and it could compromise because the jet fans push air at very high speeds and it could be problematic during a daily use of the car park.
Yeah, the high speed is for, in the jet fans, is for in the case of fire, no?
Exactly. In the event of fire, the jet fans activate at high speed because now, since we have this delay to allow all the evacuation, once the evacuation has been done, then it doesn't matter. The jet fans need to activate at high speed because you want to push all the air as possible and exhaust all the smoke produced by the fire.
Okay, we have more questions related with CFD analysis. Is there need of a CFD analysis to simulate the smoke extraction in basement? Or if we design as per code requirements, our design will be considered safe?
That's a good question. Technically, if you follow the standard and you make a good design that you know it will work, it wouldn't be necessary. The CFD is mainly to reinforce that it is a good design, but it is not something mandatory, at least right now.
Okay, and if they want to do it, they can ask for a CFD, the part of us, no, Martin?
Yes, I do many fire CFDs and CO CFDs, but this is something important in some car parks. Why do we want to do a CFD in a project? No, what do we want to see? Do we want to see maybe if this jet fans distribution allows to clear all the CO produced by the vehicles? If it is the case, then it makes sense to do a CFD. But I think that it should always have a purpose.
Okay. More questions. How we calculate the cone X and Y dimensions at low speed for jet fans? Martí, I am going to leave for a moment because I need to charge the laptop. Okay, but you can continue answering the question.
Can you repeat the question, please?
Yeah. How we calculate the size of the cone, the X and the Y dimension at low speed for jet fans?
Okay. So we have this data here. how we have calculated this, it's difficult to explain because there are formulas and it's not easy. It's a mathematical question. But basically, we refer to that. We have the jet fan, in this case, pushing air from the outlet at 20.7 meters per second. So this air velocity is being reduced by the distance. When this air speed gets to 1 meter per second, it is said that it has not enough airspeed to keep pushing the volume of air. So we say that this is the x distance. As I say, this is a formula that if you can write me in my email and we can discuss it more deeply.
Okay, I'm here again. Sorry for the interruption. You know, live things. We have more questions, Martí. Thank you so much for being this active in the chat and have all of these questions, because I think it is better for the presentation and for the training sessions. Okay, let me check where we were, in what part of the questions. Okay, more questions. If we have a car park with 3,000 cubic meter, what is the recommended extraction capacity? Is 3,000 cubic meter per hour enough based on the 10 air changes per hour? I repeat, we have a car park with 3,000 cubic meter. Mm-hmm. What is the recommended extraction capacity? It will be 3,000 cubic meter per hour enough based on 10 air changes? No, should be 30,000, no, in this case. I think it's a mistake. It's a mistake in the writing.
So basically, you calculate the volume and you multiply it by changes per hour. It's true. Mm-hmm. Yes, it's true that when you have different fire zones or different zones in the car park, imagine that you have multi-level car park with different basements, and the extraction and the supply is shared between these levels. Mm-hmm. It's true that you do the calculation of each level by considering these 6 air changes per hour of air pollution control. So it can be possible that the airflow that you get from the pollution control is higher than that you get in case of a fire, no? For the smoke extraction. So you always have to consider the highest airflow that you get from this calculation.
Okay, let's go with another question. Do we have to keep a distance of 60 meters between 2 extraction points or grills?
No. This what I show here, this data, is only for a jet fan ventilation design. If we have a smoke extraction with ducting, then it is different. But if we have a jet fan ventilation system, we say to maintain this maximum distance between this extraction point and the other extraction point to have an uniformly distributed extraction. This is mainly because we don't want to have very large distances, so you could have some dead zones in the middle that could difficult the cleaning of the car.
Good. Another question, what is the distance between two jet fans in parallel? It depends on the cone, no?
Exactly, it depends on the model and the cone and the dimensions of the jet fan, the thrust. It depends on many things. What we do when we design it is we draw the cones. So imagine I draw the cone of the jet fan of size 29, and I see that the cone doesn't is not in contact in parallel with the other jet fan. So I know I have to install a bigger jet fan in this case with more thrust.
Good. Another question related with the jet fans calculation. For selecting the jet fans, we calculate only the cone or we consider the airflow as well?
When doing car park ventilation, where we place the jet fans and draw the cones to cover all the area and do the jet fan layout properly, then yes, we consider the cone. The airflow is an additional data that is very useful, for instance, in tunnels where you have one dimension system. No, in these systems that you have a two-dimensional solutions, we use this data of the cone.
Okay, more questions. When it is recommended to use reversible jet fans?
As I explained earlier, in very large car parks of more than 100 meters, where the supply source, the supply point, is way too far from the extraction point, so the smoke that so imagine that this car park is very large, very long. We have the supply on the right and the exhaust on the left. If the fire is produced in the right area, we are pushing all the smoke towards the left, the extraction point, and the distance is way too long that it has a very high pressure losses, and we are fulfilling all the car park with smoke with no need. If instead we have a reversible system with jet fan reversibles, where this supply point is also reversible, so we have reversible fans here, and these fans, instead of supply, act like extraction, we can rather have the supply on the left, the extract on the right, and these jet fans act as reversible mode. So instead of pushing the air towards the left, it pushes the air towards the right, and the smoke is extracted more close to the extraction points. This is the main reason. There could be some other reasons where you want to maybe have some air pushed to one direction or the other based on different scenarios, but mainly that's the reason. And in this scenario, you divide the car park into zones. No? You have the right zone and the left zone, and if the fire is detected on the right zone, you activate the extraction fans on the right and the supply fans on the left, and the jet fans push the air towards the extraction fans.
Okay, so I think this is all from our part, Martí. Thank you so much, everybody, for being here. If there is any question that is not answered or there is not clear in this moment, you can write Martí and re-ask the question just to have more time to discuss it or to go in more deep. Please, Martí, share again the last slide when you put your email, and people
Yes.
can ask you for just in case there is a question that I lost or something like that. Okay.
Yes.
So thank you so much.
Mm.
Thank you so much for being here. Thank you so much, Martí, for the nice presentation and answering all these questions. And see you again on a next session of our microlearning. It will be the next month. I'm not sure the day, but it will be related to ATEX ventilation and diexplosion ventilation. So stay tuned to have more information in our LinkedIn. Okay. Thank you so much. See you soon.
Thank you.
Bye, Martí.
Goodbye.